Okay, Ben, can you just introduce yourself again and maybe the work of your company and what you do in tank storage systems?
Sure, my name is Ben Sage. Our company, as the name suggests, is primarily involved in the installation of tanks. We're a distributor for Permastore, probably the largest manufacturer of enamel steel tanks. We would do a lot of slurry storage around the country, and the remaining sales mainly treatment plants and food producers.
And biogas is an area that you're also working in?
Yeah, we've supplied digesters. The tanks are suitable for digesters, but with the market not being particularly strong in Ireland, it's few and far between generally.
Okay.
The other company we're distributor for is Bauer. It's an Austrian company. They make pumps, separators, mixers. We've been distributor for them for over 20 years. And we're also distributor for a Dutch company that make PVC coated products. So slurry bags, tank covers, and biogas holders. So I suppose the jump to biogas is as a technology supplier, we are already supplying a lot of the core components. We can package these at a distributor rate, which allows us to offer quite I think, a cost-effective solution.
Okay, and Ben, maybe for our attendees today, could you outline just the main components of the system on Brendan's farm?
Brendan's farm, yeah.
Yeah.
What
does the system
put
look
up
like?
a couple of pictures, so hopefully that helps everyone visualise the plant. The slurry is collected from Brendan's underground tanks. He's the farm's perfectly sort of designed to bolt on a biogas plant. He's limited underground storage. He scrapes into a couple of tanks with maybe 3 weeks capacity, and then has been pumping into an overground slurry store. So we're collecting that slurry relatively fresh, a week or two old, into a pumping station. We then pump to a mixing tank where Brendan can mix in silage, waste silage if he has any, farmyard manure. It's mixed and processed through a chopper pump, and then pumped into the digester. The digester is a centrally stirred reactor. You would have seen the mixers and the heating pipes. So it's processed in there, depending on volume of slurry, from 30 to 50 or 60 days. And the biogas is produced under mesophilic conditions. The digestate that comes out of it then is fed into a separator, and the separated liquor stored in Brendan's covered slurry store. The biogas then is treated before it goes to the CHP. It's the treatment process probably starts in the mixing tank. Brendan adds iron hydroxide. This will bond to the sulfur, reduce the amount of H2S produced in the gas. We'll also inject oxygen into the headspace, but this further treat any H2S produced in the gas. And then when it leaves the digester, it will be cooled down to remove the moisture content. It will be slightly reheated and put through a carbon filter, where it's then ready to be burned in the CHP.
So then the CHP unit that produces heat and electricity?
Yeah, so CHP stands for combined heat and power. So it's basically a engine burning the biogas. The heat's recovered from the heat jacket, and also the exhaust gas is also cooled down to generate more heat. And then the hot water then is used to heat the plant, and any surplus then is available for Brendan to use. I think the plan is to heat his water for cleaning the robots,
There's a large buffer tank
in
of
a buffer
storage.
tank, exactly.
Yeah.
And then additional heat, I'm sure Brendan will find uses, maybe a drying floor.
And if you follow that on then, in terms of the gas that's produced, there's enough gas to offset all the fossil energy bills on the farm, but then the surplus. So
Yeah,
the electricity goes to the grid. It all and then it's taken. Just to explain that.
So we're estimating that the plant, it's a 50 kilowatt CHP.
And sorry, there's a question been there to clarify in one of the questions. That's electrical output. 50.
Electrical output. Yeah, exactly. We're estimating 30 to 40 kilowatt, so the continuous power. Brendan uses 15 kilowatts on farm. Average 12. Using robots obviously is great because it's a continuous sort of power source pretty much. So you're not trying to fight peaks and troughs of energy use. And then the remaining energy will be used, well, the parasitic load for the plant, of course, and then the rest will be exported to grid.
Okay. And this plant are you seeing a lot of this type of plant across Europe, or is this a new adventure? And what do you see as the potential for this?
I think there is definitely potential for small scale on farm. It's getting bigger within Europe. We've delivered a few projects in the UK already. Economy of scale is an issue. Definitely needs to be granted at this scale, certainly for what we've offered. Thinking you get to a bigger scale of sort of 500,000 cow herd in all year round, it probably does stack up without subsidies, but that's not really a very representative farm in Ireland. Yeah.
And just to explain, Ben, then, if there was someone who want to embark upon a project that's here today, or someone that will be listening to this when we put up the recordings online, what is your suggestions to them in terms of embarking upon a project? What should they do?
Well, first thing is feedstocks, so see what you have. Consistent feedstock is obviously key, which, as Barry mentioned and has been mentioned a few times, farms in Ireland with herds going out in the summer does reduce the viability. But if you have your feedstocks, then the next thing really is to check grid connection. If you don't have a grid connection, while it's not impossible to build a project and run it in sort of island mode, it does complicate it quite a bit. It adds quite a bit of cost, and they can be quite difficult to run as well. So once you have your grid connection in place, planning permission is probably the next hurdle. And as Brendan said, I think it's important to discuss with the community and the planners what the project actually involves. Obviously, biogas can generate a lot of fear. People think there's going to be truckloads of waste coming through. So it's important definitely important to be as open as possible.
Okay. And just a final question for you, Ben, before I go on to Noel and Barry, just for a couple of comments and also take some questions. Automation of this type and scale of plant. So how automated is it? Barry would have referred to that in his slides. Can you just explain how does Brendan monitor the plant and what input do you have in that?
It's as automated as any biogas plant, really. The whole system runs based on a system of processes that's pre-programmed. You can alter the settings, change flow rates, etc. But basically the plant will run away in the background, with the exception of feeding the feed tank. This is a manual operation. Technically, if you didn't add any solids, Brendan could fill the tank from his phone in his house, in his bed, on a Sunday, but there'll be no solid material going in there. But other than that, then the plant is automated and monitored by phone, and any alarms are sent to Brendan. So, I mean, it complements, I think, farmer with robots perfectly. You need to be around. Majority of the time it's running around in the background, but there could be a point where something trips out And the quicker you get down there to check it out and sort it out, the better the plant runs.
Okay, Ben, I know Barry wants to come in, but just if you take that microphone, because we wouldn't hear it otherwise. So
Yeah.
I just was going to ask you a question. Would you maybe put a figure on it? Because a lot of people would ask the question, labour is a big issue on farms at the moment.
Sure.
And taking on this technology is going to obviously eat into maybe more of those hours, those limited hours of time available. I know Brendan has a family and probably help there as well, but other people that maybe don't have that labour backup, would you just comment on maybe the hours per day that will be required to keep this animal fed?
Typically 30 minutes to an hour is all that's required. Majority of that will be actually feeding the mixing tank. While that's sort of in process, you can do basic checks of looking into the digester window, just walking around, checking for unusual noises, smells, and that's basically it. But as I say, something could trip out, and it might require 20 minutes, an hour's work. You can't guarantee when that'll happen. So again, guys with robots is perfect because they're generally around. They're not tied into milking for 2 or 3 hours a day, 2 times a day.
Okay, Ben. Stephen, have any questions of the Slido? Apart from the one we had about the output, it was based on electrical output. So it's just to clarify for one of our attendees. Are there any questions for any of the audience? If you just raise your hand if you have a question or any comment or feedback. There's one at the back. When will the plant be up and running? So the plant is currently been near the end of its construction, and then will have to be commissioned. So a lot of it will be up and running by the end of the year. Isn't that correct, Ben? Yeah.
Yes.
Yeah.
Exactly.
Yeah. We'll demonstrate it then, Seamus. It'll be summer. Longer days, better weather. It'll have ran for a few months. So it'll be next summer before the demonstration farm visit will take place. So.
Can I just ask a question here, Sean, of Brendan, maybe? Just in terms of the feedstocks that you're going to use. Now, I know you're going to use cattle slurry and all year round, but do you plan to maybe work with your co-op and taking in the likes of dairy sludge from the dairy co-op and use that as a feedstock? So it's probably, from a circular economy perspective, it was something that was originated on your farm, it was processed in the dairy co-op. Would that be something that could come back to you and that you could use, or is there any other feedstocks that you're thinking of to keep it fed all year round?
No, I'm going to be a closed gate system, so it's whatever we produce inside. I suppose our heifer slurry and dry cow slurry will be treated with preservative or gas retainer products. There's two companies we're talking to about using their products on trial base. So they help retain the gas yield of the slurry, so we can use that during the summer, so we can pump that up to the dairy cow tanks and put that through the digester when we're running a bit lower on milk and cow slurry.
And we'll hear more about that in the afternoon. There's a special session in the afternoon where we'll be to cover on that particular topic. But
dairy sludge now. I suppose it's for an organic farm. It is allowed to be used, but I won't be using it. I'm keeping my gate closed there.
It is an option for some farms if required, though, and it could be used.
I think it's important to point out as well, Brendan mentioned the preservatives. That's something really just new come on the last 5 years. One developed in NUIG.
We'll focus on that, Nolan, after lunch. No, we won't go into it now in great detail because it'll be covered after lunch. Okay. Is there any other questions from the Tim?
I have a question for Barry, if that's
Go
okay.
for it. Yeah.
I noticed in California, if I look at Frank McDonough at the University of California, Davis, he seems to have a low technical kind of system for storing the gas in low earthen slurry storage basins and then sealed overhead with heavy-duty polythene. Have you looked at anything like that for an Irish context, which would greatly reduce the capital cost?
Yeah, there was the Italian guy that had that system. They were using the bag system. Was probably the closest that we would have seen to that. It was what was it called, that system?
We won't bother mentioning names, but we'll keep going.
It was another type of system. There was a bag system looked at a couple of years ago. It was probably demoed on Hayes' farm. That was featured there in one of the slides earlier on. It is a lower cost system, but didn't really get much traction, I suppose, and I wouldn't rule it out, because there's still a possibility. It's a lower cost system that you're not putting in those concrete tanks, but there's still a possibility that could be financially viable if there was some kind of a support mechanism there, but that's why it didn't work.
Okay, there's a question in here, and thanks Tim for your question. What maintenance breakdown support is there if issues arise at the plant, and is there an ongoing cost to the farmer for this backup? So, Ben and Brendan, do you want to expand on that?
Well, our company will be there to support with the mechanical, electrical components. We'll have a separate CHP contract with a company specialised in maintaining CHPs. That will be a sort of annual cost going forward. In terms of maintenance on the M&E equipment, we would sort of work on a need to call out basis.
Okay, and I suppose you're familiar, Brendan, with maintenance of your robots and that, so maintenance of this system will probably it adds another system to your already a number of systems, is that correct? So you're not phased by that or anything to do with it?
No, I wouldn't be afraid of taking on any mechanical issue. One of my sons is doing mechanical engineering, and he's very good at all that sort of technical stuff as well, so we've no fears.
And costs, not probably significant in the greater scheme of it, is it, from an annual cost perspective in terms of that technical backup and maintenance?
Yeah, CHP, I think, was it figures maybe 10,000 per annum, 5 to 10,000, and plants probably, year one will be very little. Everything's new, so it will fluctuate, but average maybe sort of 3,000 per annum.
Okay. Any other questions? Is there any before we close down for lunch? There's one here. If you could just state your name and your organisation. I forgot to ask Seamus to do that, so it's Seamus from IrBEA's and Tim is Biogas. So just if you could state your name and your organisation and your question. Do you mind maybe if you come up to the podium, it might be able to hear you, so we don't have a roaming mic. So if you just come forward and maybe ask the question here through the mic. Yeah, thank you. No.
Good. Yeah, I'm Jidong from Chagask. So I mentioned about organic farming. So the digest could be used as fertilizer for organic farming. But if we recover, we may produce excess digest that if we build more 80 plants. So if we recover fertilizer from digested, other products could be used for organic fertilizer, because the fertilizer recovery is really similar to the synthetic fertilizer, like commercial fertilizer. Other could be used for organic farming.
So Barry,
so the question you're asking is it possible to use the digestate on the organic farm?
No, I mean the fertilizer from digested.
The nutrient, the makeups, the P's, the K's, so separate all that out.
Separate from digest out. Yeah. Could that be used for the organic fertilizer?
Yes, it can be. So it can be separated out. So the liquid component, you generally have your nitrogen, and the solid component, you have your phosphorus and your potassium, or you have your fibres.
Yeah.
So that can be separated out, and that can be used. If you don't require phosphorus, if you're high in your P's, you can just go with your liquid material, which is your nitrogen, back onto your agricultural land.
Yeah, that's allowed for the organic farms.
Yes.
Right.
Yeah.
Okay.
Okay.
Thank you
for your question. Any final questions before we close up for the lunch? break. Again, you have the option of putting it into the Slido if you want to ask questions that way. If not, I'm happy for you to take a question from anyone from the floor. Okay, there's one there, yeah. If you shout, we can hear you. If not, you'll have to come up.
No worries. How long do you anticipate the commissioning to take place for the culture of anaerobic bacteria to form and get the plant full capacity?
Probably the longest.
So maybe repeat the question just for the purpose of the camera. So it's how long to commission the plant in terms of getting bacteria up and running, yeah? The
plant and get bacteria up and running. Probably the longest process is actually heating the plant or heating the digestate up to 30 degrees. Once you hit 30 degrees, with it being slurry, it'll start to produce gas. And I would say, so 2 weeks to probably get the temperature and another week or two to get to full production.
So it's relatively short period.
Once you hit 30, 35 degrees, it's gas in the way.
Okay, any other questions from anyone? Okay, well look, I thank you for those questions, and I thank our panellists. I thank Brendan, Ben, Noel and Barry. We will be delving into some of the other issues associated with this scale around research. We have a so Ciara will present after lunch. We have Joseph from Bioelectric who will present about this scale at a European level. We have Chris as well who will present about interesting work that's happening in the Northern Ireland around slurry separation and digestate separation. And then we'll hear a panel discussion from Seamus Gallagher and Stephen Nolan from Glassport Bio and from IrBEA's about innovative developments within the sector and particularly around this scale. Just one thing before we finish up, there is a survey on Slido. We would encourage you during the course of the day to maybe input your feedback through that to the Slido. There's a few questions there we have which would help us to inform our final report. And if I could just maybe, one final point was that the carbon abatement analysis is ongoing. It will be bolted on to the online tool that's there. But Noel, I forgot to bring you in maybe just to comment on the carbon abatement from the Gildea farm. Do you want to just maybe comment on that before we finish? Because it's quite a significant figure, and what makes that up?
So the carbon is made up by two factors. One is the displacement of fossil fuels, and the electricity and the kerosene. So that's working out at around 80 tonnes of carbon per year. But we're still working on that's. We're quite happy with that figure, as in we're quite confident in that figure. We're still trying to determine the saving from emissions from the slurry. You know, if you've got erroneous emissions from slurry and storage, so by displacing that, the figure could be upwards to 800 tonnes a year. We don't think it'll be actually that high, but it's definitely that's where the scope is. So we have to land on a figure on that yet. We're not going to publish a figure on it just yet, but it is something that where there's definitely the most significant impact.
So that's specifically to Brendan's farm.
It's basically capturing the methane that would normally be emitted by slurry and storage. That's being captured and extracted from the slurry. So
okay, and just as a follow-on, then Noel, the other calculation around emission saving is around the displacement of chemical fertiliser on potentially the other two farms, and we will be doing a carbon abatement analysis for the 3 farms that we've profiled today. But both of the other farms are using chemical fertiliser. So can you just explain that, how we could see a reduction in chemical fertiliser by producing digestate?
Yeah, so if you look at typically on a farm, the nutrient management planning, most of the majority of the nutrients are actually coming from the slurry, not from fertiliser. Your fertiliser is top up. But when we increase the amount of availability, by turning your slurry and your farm manure into digestate, you're breaking down the organic components. It means the nutrients are far more available for plants, and the uptake is a lot better. We see that even farmers that are using digestate themselves will tell you the impact it has. It becomes you can actually put digestate into your grazing system, into your paddocks, which you wouldn't do normally with slurry. So that increased availability of the nutrients means you've less requirement to buy in chemical fertiliser. And that has a significant impact on the overall impact of both from the carbon production from nitrogen, for example, and from the other products that you would have. So it has a significant impact.
Okay. Sorry, I forgot to bring you in, Noel, but that's a very important aspect associated with this project. And again, this will be outlined further through the work of between IrBEA and Brendan's situation and the other two farms on Kira as well from a Teagasc and Barry from a Teagasc perspective. So, okay, well look, we'll close for lunch at this point. The lunch is immediately just outside the door here, and we'll reconvene at 1:45, just 15 minutes later than scheduled. But I look forward to seeing you all then. Thank you.